Hey, everybody. Thanks for joining me today. Today, we're going to work through lesson 2.7. I think of it as solving for variables and then using it, like applying it. In the book, if you're looking in the book, you may see these sometimes referred to as literal equations. Okay, so it just really depends on how you're trying to break it down. Today, the big key is we are going to practice solving for x, but it's not always going to look like that. It might not be the letter x. What we're used to is the idea of getting x by itself. And of course, what we are used to is the idea that we usually end up with a value or we end up with a number. Like for instance, usually we're used to things like this: 5x minus 3 equals 27. And you know what to do from here. You add 3 to both sides, okay? Then you finish up the problem. As soon as you know that 5x equals 30, you and I both know you're only one step away. You divide by 5, and it turns out x equals 6. You knew that. There's none of that you haven't seen before. The difference today is that today, now you're going to get things that look like this. You may still be solving for x. It may be another letter, but it'll look like this: ax plus b. Well, let's do minus b. That way it'll be exactly like what we just had on the left, equals c. Now, both of these, the directions are solve for x. But it means very different things because now we don't have any numbers. We don't have any numerical values. We just see ax minus b equals c. The good news is the same strategies that we used on the left, we can use on the right. So instead of going plus 3 and plus 3, we can go plus b and plus b. It might not necessarily be what you were expecting, but if the goal is to get x by itself, that's what we're trying to do. That would give you ax equals, and then over here we have a b, we have a c. I don't know what they are, so we have to just leave it, b plus c. And that is the first step that really starts throwing people for a loop. You get this right here, 27 plus 3. Oh, that's 30, of course. But when you get something like c plus b or b plus c, sometimes it doesn't make quite as much sense. Anyway, once you get there, just like we divided both sides by 5, we're going to divide everything by a. So I don't know if you noticed this yet, but we did solve for x. We got x by itself. What does it equal? Well, I guess we're just going to have to leave all of this here. We don't have a good answer. We're just going to have to call it b over a plus c over a. Now, sometimes I'll get a student who wants to leave it all together and do b plus c over a. If that's the case, great, good for you. I am actually going to suggest to you that you keep this one in mind because it's going to make a lot more sense when we finish this whole thing up. All right. So let's go to a question that doesn't have any x or anything in it. D equals RT. Solve D equals RT for T. This is one of my favorite equations in the universe. I call it dirt because if you were to put a little line through the equal sign, it turns into an I, and now we have dirt. There you go. It is the dirt equation. Okay, maybe that's not really good for you, but it's what I always say. Distance equals rate times time. And you actually knew that. Like if you were driving 75 miles per hour and you did it for 2 hours, the distance that you traveled would be 75 times 2, which would be 150 miles. So you knew that equation was true. You just never really thought of it that way. So if it says solve for t, a lot of my students, they look at it and they just say, well, we don't even know what D and R happen to be. Like, we have no clue what's going on. And so usually you get a couple kids who quit. It's not a big deal. Remember, solving just means getting it by itself. What is keeping the t from being by itself? When we have d equals rt, why is the t not by itself? What is keeping it from happening? Well, it is being multiplied by r. So how would you undo it? Well, what's the opposite of multiplying by r? You would divide both sides by r. Okay. So let me show you what this would look like. If you had d equals rt and you had to solve for t, your goal is to get the t by itself. So we are going to divide both sides by r, and that cancels it out just like that. And you end up getting t equals d over r. So time equals distance over rate. Okay. All right, now what if it gets harder? What if you're dealing with things involving y's? Now, the reason this is applicable to you now is that you are going to eventually have things you have to do involving graphing. So you're going to get, say, 2x plus 3y equals 9, and you are going to have to graph a line. Now, the catch to this is that if you have a TI graphing calculator, one of these where you have the y equals when you try to graph, the problem is they have it written y equals. So you cannot graph with a TI graphing calculator unless you have y by itself. Now, some of you might look at this and the first thing that you might think of is y equals mx plus b. And you're right. That's what we're doing. The graphing calculators that you usually buy will not graph unless y is by itself. So we need to practice getting problems like this into that form, which, in case you forgot or never learned it before, that is called slope-intercept form. But that's what we're going to practice. That's why we do this. Well, that's one of the reasons why we do this. Solving a literal equation sometimes means just solving for y. Okay, so that's what we're going to do. Kind of similar to before. Here's the deal. Let's back up a second. Why is y not by itself? Y is not by itself because, well, there's a 3 next to it. It's being multiplied by 3. That's not good. And then you'll see there was a 2x added to it. So if you're looking to see, well, why did he just subtract 2x from both sides? I'm doing the reverse of everything that happened to y. It's sort of like using the order of operations in reverse. So instead of adding 2x, we are going to subtract 2x from both sides. Okay, so let me show you how this would look. We're going to subtract 2x. We're going to subtract 2x. Once from the left, once from the right. That's going to give me 3y equals negative 2x plus 9. Resist the temptation to make the rookie mistake of trying to combine these. These are not like terms, so don't try to combine them. Just put them next to each other. From there, we just divide everything by 3. Okay, and that's something I wanted you to write down. Divide both sides by 3. And clean this mess up, and you get y equals negative 2 thirds x plus 3. Okay. All right, let's try a few more that look just like that so we can practice the whole process. If we want to get y by itself, we need to move the x to the other side. Okay, so 4y equals negative 3x x plus 12, and then divide both sides by 4. And I'm going to break it down step by step. And again, the reason I do that is so that we can get in the habit of using that mx plus b thing before it even comes time to graph. You will be so good at getting it in this form that you won't have to worry when it's time to graph, because when it's time to graph, all you're going to have to do is take your slope-intercept form and use it. Which actually, here's a quick example for you. Think about that one that we did early on. And think about how I showed you on Desmos how you could graph it. Look at that. It's the exact same graph. The scale is different, so it kind of doesn't look exactly the same, but I think you and I both know that it is. Okay. All right, let's try a couple more just to make sure you feel pretty good about what's going on here. Subtract x from both sides. Now, this one actually throws a lot of people off because we end up getting just x. There's no number in front of the x or anything like that. So people look and they wonder, well, what do I do now? There's no number next to the x. And what you do, if you want, and I think it's actually a pretty good strategy, if we don't know how to handle this situation, a negative divided by a negative is a positive. And if we want, we can put a 1 next to the x. Now, we don't always do that, but in the case of mx plus b form, I think it's actually better to put a 1 there, because then when you look, you can just call it 1/7 x plus 2. And again, that's because a negative times a negative is a positive. Okay, one last little note here. This last problem, we subtract 4x from both sides. So now you've got negative 2y equals negative 4x minus 17. And then when we divide both sides by negative 2, now you've got y equals 2x plus, and I can't do anything about this, so I'm just going to leave it 17 over 2. Now, in the future, a lot of people have been freaking out about what that actually means. Like, why would that be a thing? What does that actually represent? What that would actually represent is that 17 over 2 is 8.5, which means once we get into the graphing chapter, what you'll find is that when we graph, sorry, I zoomed in too far, the intercept, the y-intercept, the place where the graph will cross, will be at 8.5. Okay? So real quick, what I want to do last is I want to turn to the back of the paper. And I bring up the back of the paper because there's some good application here, and I want to make sure you understand where it came from. So here's a problem. You're going from Phoenix to Fresno, 480 miles. It didn't say Phoenix, but I was the one who wrote the paper, so you can guess that that was sort of what I had in mind there. Anyway, we learned in the very first example that time equals distance over rate. So the real life application of that is that if you were to go a distance of 480 miles and you were to travel 60 miles per hour while you do it, you could divide to figure out how long it's going to take to get there. Like if I were to hit the road and I were to go a couple hundred miles and I were to go 50 miles an hour, I could do 200 divided by 50 and find out that it would take 4 hours to get there. In this case, 480 divided by 60 is 8. Okay. Now I want to work on application, so I'm actually going to skip 2 and I'm going to go to 3. How would you take this method, which is actually a thing, that is a formula to change Fahrenheit to Celsius and vice versa? How would we solve for C? So how would you take this thing right here, and I can actually just copy and paste it. How could I solve for C? How could I get a final answer of C equals instead of F? And what I would do, I would think the same way that we've been doing, subtract and then divide. So F minus 32 equals 9/5 C. Now, lately we've been subtracting and dividing. So let's divide here. Well, if you divide by 9/5, that seems kind of weird. How about we do it the other way around? Remember, dividing by 9/5 is the same as multiplying by 5/9. Okay, so that's what we're going to do. We're going to multiply by 5/9. That's going to cancel this. That's going to cancel that. And we're going to get C equals 5/9 F minus, and remember, we're really just distributing here. 5 times 32 is 160. And then this 32 is just 32/1. So I'm going to say 160/9. Now, that doesn't look pretty. I mean, you don't probably feel like you accomplished a whole lot, but that is the equation we're going to use, which brings us to part B. One day this summer, it reached 120 degrees Fahrenheit in some parts of Phoenix. True story. If you were telling your friend in Mexico about it and they use Celsius, how hot would you say it was? Well, we could take that information. We could take that 5/9, which, by the way, some kids ask me, what is the fraction button on my calculator? Fractions are just division. So if you can't find the button, and I know I'm not there, so I can't really help you, just use parentheses and then close them up, close up the division problem. That's really all you got to do. So this is the way I would enter it in a calculator if it were me. And it would, in fact, give me the final answer I'm looking for, which is about 49 degrees. So if you are in a country that uses Celsius and they say it is going to be 49 degrees outside, that is stinking hot. All right. Well, I hope this helps you get on your way with your notes. Feel free to wrap up the rest of them so that we can get it checked in a couple days, whether you are in person or whether you are online. I'm going to want to take a look at these and see how far we get here in the next couple days. Thanks for your time, and I'll see you next time.